So now we will see another example of solving a difference equation by using Z transform. So this is your difference equation, okay, with two initial conditions. So we start with applying Z transform on both sides. So what we get? Z transform of yk plus 2 minus Z transform of 5yk plus 1 plus Z transform of 6yk equal Z transform of 0. Okay, then we name these terms as 1, 2, 3 and 4. We say 1, 2, 3 and 4 and we solve them separately. First term, Z transform of yk plus 2. So now we are going to use that formula. If Z transform of yk is denoted by f of z, then Z transform of yk plus 1 is zf of z minus z y0. Z transform of yk plus 2 equal to z square fz minus z square y0 minus z y1. Let me write it here, minus z y1. Okay, so substituting this thing there, what we will get? Z square fz minus z square y0 minus z y1. Now we can see the value of y0, y1 from here, 0 and 1. So it is z square fz minus z square, y0 is 0 minus z times 1. So this cancels to 0. So we left with z square f of z minus z. This is for the first term. Similarly, for second term, Z transform of 5 yk plus 1. First of all, 5 is a scalar, take it outside. Z transform of yk plus 1. Use this. This gives you 5 times Z transform of f of z minus Z transform of y0. The value of y0 from here again, 0. So this gives you 5 times zf of z minus z times 0. So this cancels to 0. So this gives you 5z f of z. Third term, this is separate. So third term is Z transform of 6yk. Again, 6 is a scalar, take it outside. Z transform of yk. Yk is nothing but f of z. So this is 6 f of z. And fourth term is Z transform of 0, which is 0. Now substituting all these values in this equation one by one. For first term we have z square fz minus z minus, for second term, 5z f of z. Third term plus 6 f of z equal to 0. So next step, as usual, keeping the term with f of z on the same side, term without f of z on the other side. So when we keep the terms with f of z here, we get z square fz minus 5z fz plus 6fz equal to, this is minus z, moving on the other side become plus z. Now take f of z as a common factor. What it gives? Z square minus 5z plus 6 equal to z. So this gives you the value of f of z as z over z square minus 5z plus 6. Now f of z is z transform of yk. So let me write it on the next slide. So z transform of yk equal z over z square minus 5z plus k. Again, it's long, but the method is easy. So to get yk, we apply inverse z transform on both sides, which is z over z square minus 5z plus 6. Now see, in this case, when you have to take inverse z transform, you have to make factors of this first. So we know that z square minus 5z plus 6, we can write it as product of two brackets, z minus 2, z minus 3. So this will be inverse z transform of z over z minus 2, z minus 3. Now it means its product, we have to use partial fraction. Now for partial fraction, we are keeping one z safe. So when we use for partial fraction, we use the term, now if we take z from here, we left with only 1. 1 over z minus 2, z minus 3. So we have to do partial fraction for this. A over z minus 2, b over z minus 3. So now I quickly solve it because I am sure that now you are expert in this through my previous classes on this topic. So it is z minus 3, z minus 2, 1 over z minus 2, z minus 3. So comparing the numerators give you 1 equal a times z minus 3, b times z minus 2. Two constants a and b. So two values of z. Z is equal to 2 from here. So 1 equal a times 2 minus 3 and b becomes 0. So this gives you a as minus 1. And from here z is equal to 3. So this gives you 1 equal a times 3 minus 3, b times 3 minus 2. A term becomes 0. So this gives you b as 1. So now we substitute these values over here. So what we will get? 1 over z minus 2, z minus 3 equals a, which is minus 1 over z minus 2 plus b, which is 1 over z minus 3. But actually our yk is z over z minus 2. So when we write yk, which is inverse z transform of z over z minus 2, z minus 3, it means in this case we have to multiply both sides here with z. Multiply with z. So this is same as inverse z transform of minus 1 into z is minus z over z minus 2 plus inverse z transform of z over z minus 3. Now apply the rule. So for this minus sign outside, z over z minus 2 gives you 2 to the power k plus 3 power k. This is the value of yk. Now you can check whether this answer that you got is correct or not. How? See, the initial condition was y of 0 is 0, y of 1 is 1. So if I put k is equal to 0, what I am getting? Minus 2 power 0, 3 power 0. Any number power 0 is 1. So you will get minus 1 plus 1, which is 0. So it satisfies first equation. If I put y equal to 1, I get minus 2 power 1 plus 3 power 1, which is minus 2 plus 3 gives you 1. So see, the value is 1. Again, this is a method for checking. It's an optional. Your solution complete at this stage.